Welcome you all. Today we are going to discuss about traveling salesman problem from Unit 5. So what is this traveling salesman problem? We all know what do you mean by traveling salesman problem. A person have to visit all the cities in a shortest distance, and he has to return back to the same city where he has started. So this can be solved using your approximation problem. There are three types of algorithms for traveling salesman. One is nearest neighbor algorithm, second one is multi-fragment heuristics algorithm, and third one is twice around the tree algorithm. This can be solved using these three approximations algorithm. Okay, today we are going to discuss about this multi-fragment heuristic algorithm way of solving this traveling salesman problem. So what is the step 1 in this multi-fragment heuristic algorithm is we have to sort the edges in the increasing order of the weights, and we have to set and we initialize the set of the two edges to be constructed to the empty sets. And then we have to repeat this step n number of times, where n is the number of cities we are supposed to visit, and we have to add the next edge on the sorted edge list to our tour list. Okay, and we have to keep it in mind that none of the vertex of the degree should be 3, and we should not form a cycle whenever we are adding the edge. If so, we have to skip that particular edge. Whenever we are adding a new edge in a graph, we are supposed to calculate the degree of each and every edges, so that none of the vertices should not have the degree of 3. Okay, then we have to return the set of two edges. So we will see an example. Here I have taken an example of this graph. Okay, so here we have four cities, four vertices. So the n is equal to 4. Now we are going to solve this problem using the multi-fragment heuristic algorithm. As I said, the first step is sort the edges according to the increasing order. So A and B is the smallest edge, so A comma B. Then we have value as 2. Okay, so I have D and C. So D and C is also 1. Then I have value 2, so it is BC. Then I have value 3, it is AC and BD. Then finally I have AD. So I have sorted the edges in the increasing order. Initially I don't have any edges. So I start with adding the shortest edge first. So first I am adding the A to B edge as the first edge. Okay. Then I am checking the degree of this edges. It is 1 and B also 1. Then I am seeing to DC. Okay. So if DC is added in my two edges, what is the graph I will be getting? So I am just adding. So there is also no degree edges forming a degree of 3, and then I am moving on to next edge, it is BC. So if BC has been connected, so what is the degree of each and every edge? So A remains 1, B remains 2, C remains 2, C is became 2 and D remains 1. So nothing happens when adding BC. Then the next edge is AC. So if AC has been added, what happens? Cycle of length 3 is formed. See here, your C is in degree is getting as 3. So I am going to neglect that. Any edge when it has been added, if it gives an degree of 3 for any of the vertices, then I have to skip that particular edge. That is what my algorithm says. So I am going to neglect this A and C. I am moving on to the next. So BD is then another edge. So BD, if it is added, so what happens? It gives an degree of B. For B vertices, the degree becomes 3. So that is also will be omitted. Then finally, I have DA. So DA has been added. So when DA has been added, none of the edges is getting an degree of 3. And finally, since I have visited all the vertices or cities in my graph, I can go back to A. So now the cycle formation is acceptable. Before visiting all the cities, I cannot have a cycle. So this is an two edges. So AB, BC, CD and AD using your heuristic algorithm. So the total cost is 10, whereas if we solve the traveling salesman problem using same Prince and Kruskal algorithm, actual cost is 8. Okay. So the solution obtained here is as I said, it is an approximation algorithm is nothing but it is going to give you a solution more or less nearer to an optimum solution. So hence here it is 10. So this is an approximate algorithm. We will see about nearest neighbor algorithm in the next video lecture. Thank you.